Today I'm mostly here representing the open source co-chair position, and along with that, my colleagues in the open source focus group of ORAN. So where did ORAN start? ORAN was a merging of the CRAN initiatives and the XRAN initiatives that had very complementary goals. So it was a very nice merger. You can see here there's 5 founding members that established the organization back in 2018, and it first started meetings in person in February of 2019. Its mission is to develop open RAN, introduce intelligence into the network. Both the CRAN and the XRAN had those aspects, so that was a nice join in there. It also virtualizing the implementation so that we can decouple the software from the hardware where possible. And the fundamental goal was this interoperability. So as we disaggregate the RAN into its constituent parts, we want to be able to allow disruptors to come in and not be just the incumbents that traditionally would provide your RAN elements. And this allows us to look at best of breed and flexibility and increases innovation. So the ecosystem is pretty large. You can see here we have over 300. It's divided. You have members, and then you have contributors and academic contributors. The members are more the operators, and the contributors are the vendors and academia. And so there's quite a big list here that is. You can see that the community is pretty diverse. You see this on the side of the slide here. We have people from academia, application developers, chipsets, cloud providers, government is involved, hyperscalers, the network equipment vendors, operators, research institutes, security. You can see the list is pretty long there. Its focus is on 3 main things. Okay, specifications. So it's a standards body. It generates standards, largely not to duplicate. It's to leverage. So we look to what's been done before first, especially in the areas of 3GPP and ETSI, because we straddle 2 different communities in certain aspects of the ORAN ecosystem. And so we look at both of those. There's a testing and integration certification process. That's so that vendors who are compliant to the standards can be badge tested and certified by an independent testing facility. And therefore then they can use that badge. That way operators have a certain assurance that they comply to those standards. Okay, and then there's the software community, and this is an open source initiative. ORAN started with the assumption that you really can't do you can't do standards, especially for software, without having some implementation of software, reference implementation or demonstration capability. And so they started the actual ORAN software community as a co-thing. The ORAN itself has these, overall there's the technical steering committee, there's 11 working groups, 5 focus groups, 2 committees, and 1 research group. You can see that they're all sort of broken up. In the very center of this is sort of the ORAN architecture loosely. It's not exact from the ORAN documentation, but it's a good representation. We have these ones on the right are more stacked, very specific, like layers of the things, starting with a high-level architecture in Working Group 1, and moving down to your open front haul transport, down at towards the bottom of the stack. Over on the focus groups, they are more spanning the whole thing. They don't necessarily focus on one specific area, and so. When we look at the open source focus group, they're looking at all the aspects of the working groups and where in open source, not necessarily just in the ORAN source community, but across all open source initiatives that they might find references or implementations of the ORAN architecture. And then the next obvious question from that is looking at how do you harmonize that? How do you make it interoperable, or how do you make it more complementary than competitive? Okay, since it's been working this slide is a little dated. It talks about our July. We're just now closing up our November train. But there's been a lot of specifications that have been developed. The thing to note on this one is that at the bottom, we start seeing that part of our goal is, as many of these, is that they are introduced to the public in Europe. And so a lot of our documents go through the ETSI PAS process in order to get republished in as ETSI specifications. And that way they're available to European operators for use in acquisitions of equipment that's to be compliant. And here you see that we work a lot with ETSI, but they're not the only one. You can see we also are working with, we have working agreements with GSMA, OII, and GMN. You see OAI in this list. And actually that's deepening, that's a very deepening relationship with OSC as we try to cross-connect the parts and potentially even look to eventually harmonize some of the pieces to the puzzle. So the open source in ORAN, we partnered with the Linux Foundation. So the OSFG is the ORAN component of that. They are formerly a focus group in ORAN. The software community is externally, it's founded by and sponsored by ORAN, but it is actually run as an independent. So we have a slightly different reason. We participate in their face-to-faces, but we don't use their bridges because as an open source community, our rules for public exposure are slightly different. We have a totally transparent open source model. And ORAN itself also has an open policy for the data, but it has to be published or given by a member or go through the public website. So in the ORAN software community, it says 13 projects. That includes the OCU. The OCU is long, in OSC is long dead. It's been archived. We're on release K that we're closing out now. The OCU's last release was in C, or Cherry at the time, and so it's deprecated. The other ones in here, you see there's the infrastructure. That's our OCloud. There's an integration and testing project that try to bring them all together in more than just pairwise connections. And in some cases, we're doing end-to-end call flow. That also includes bringing in components from OAI. We are currently doing things where we have the OSC ODU high connecting through the OAI ODU low. Even though that's not a formal integration point of ORAN, it uses the FAPI interface or a version of it. We've got a new mapping function called XFAPI that we're working in this release that actually allows you to choose whether you're going to traditional FAPI and the FlexRAN from Intel, or you're going through the OAI interface to that, and without having to actually change your code in the ODU high functionality. So that's very interesting. It's interoperability we hadn't expected because it wasn't part of the standards per se, but we're demonstrating that it does work. You can see here we have lots of X apps that have been developed for the near real-time RIC. We have a near real-time RIC platform that's independent of the FlexRIC that was in OAI. However, like the OCU, we are using either a binary given to us with license from Radisys, or we use the OAI instance depending on which lab we're in. Okay, so let's go and talk a little bit about this challenge, because they set themselves up in ORAN saying, well, we're going to have a standards body and we're going to have open source. The problem is when you start developing spec-like products, okay, or code-like artifacts, because it's software or software readable, software integratable, then you need to be able to put that into your repo in order to do a build in open source. As soon as you do that, you're now republishing somebody else's work, and that's a copyright infringement. And so we immediately ran into this back in 2020. As soon as we started doing some builds as this ORAN specs started to emerge, we found that we had copyright problems. And so we've been working on this process. How do we get it so that all the interested parties have the flexibility they need without incurring a copyright infringement issue? Or going through the burden task of, like for 3GPP, we have to list every spec by clause that we are taking content from and putting into our software. And that's a very, very long list, and it's by release. So every time we upgrade to a new release, it would have to be changed. We incorporated software that we demonstrated in open source for how to become where you could just reference their specifications, their JSON files or those type of schema defs, but we can't actually include them in our build. So what do? We create our own. We use it in place. We do our demos and stuff like that, but we're not compliant to the standard because we can't use the standard definition. Okay, but we need a way then for that the standards bodies can still maintain control of their definition. Otherwise it's no longer a standard. I heard a conversation this morning about, they're talking about you don't want it to splinter and become a de facto. That's a bad practice or away from the actual standard. And that's true. That's exactly the goal, is that you want to be able to follow the standards. But if we want open source to be adopted and incorporated into products that people will actually use, then you'd want them to be able to have the standard into the open source so that it can be readily adopted and not have to be modified after the fact. So this is a pictorial of that problem, is that ORAN, it creates these, in this case the example are Yang files. I'm in working group 10, so of course I picked Yang. We do a lot of Yang. But in this case it's a dictionary. And we use dictionaries to define alarms or performance measures. And there are standards that tell you what the descriptions of those are. And so we have a hard time implementing that when we bring that in, because it would have this reference into 3GPP and ETSI. We use both. We have standardized faults, and we reference in performance specifically, we reference both organizations for ETSI-based standardized faults, performance measures, versus 3GPP standardized performance measures. And that's because the cloud is aligning more with the ETSI, but the RAN is aligning with 3GPP, and we straddle that world. But if you try to do this, you take that copyrighted, you then, it's a code-like file, you use your tools to incorporate it in, and it generates this new form of a production of the copyrighted materials, and you want to include it into your repo, and that's not allowed. So that's the simple problem. So we introduced this concept as we've been working on it since 2020. Okay, the Standards Collaboration Copyright License, and it's a new license model that is attached to the document, to the standard. Okay. And it allows the SDO to share that code-like portion in theirs and make it available at a public place. And then the software communities can bring it into their repos. Okay, they can even modify those and still maintain the license headers on the files. So you have, just like other open source products, you have clear traceability back to the originator of the license and where it belongs and who owns it. And that way that everybody has the abilities that they need. Open source can modify, downstream consumers can modify, okay, but the SDOs maintain the ownership and a clear path to that. And so this is an example of the flow. We've talked about the fact that you need that feedback loop. I can cite you several examples where we've actually been doing the implementation in OSC of an interface while the actual specification is being written. In fact, we have some of our code developers that are actually attending some of the ORAN meetings for the development of the product, because they're doing it literally in parallel. We demoed our topology and inventory capability at the last face-to-face, while we were still working on and haven't yet published the actual stage 3, how to implement it, document.
1 minute, please.
Yep. So, last slide. So here we are with where we're at. Okay, we just got this work. There's tools that are being incorporated into the work groups. And so the November release, this train, will put things into it. As it goes through the release process, there's a 60-day IPR review before we can actually publish. So we won't see the actual publication of these Yang files until the around March, and that's when we will actually then bring it from the repo of ORAN into the repo of OSC or Linux Foundation. They have a project ready to receive it. They've had to modify their licensing to support this new SCCL license. That was part of the delay, is getting all that. But then, starting then with our next release, which will be our RL release that goes into June, we'll be able to actually reference the actual standard specs as produced by ORAN. Okay. Still need to work with ETSI and 3GPP to try and see if we can't get them to adopt a similar mechanism that we can then go forward.